The first thing is, so there will be some line will be connected, some transformer will be connected, some shunt reactor, some capacitor bank, all this will be connected in a substation. Correct or not?
Yes, sir.
So if I say the screen is visible, is it not? Hello?
Yes, sir. Yes, sir.
So if we say a power system diagram, so that is saying some generator, right? This we have seen in, correct or not? This type of line
Yes, sir.
diagram
Yes, sir.
we have seen in the book. There will be some generator, then there will be some transmission line, then there will be some transformers, correct? Then there will be some outgoing, incoming, outgoing, something like that, correct? And there may be many, correct? Another. So this is called a substation, correct? The screen is visible, and whatever I have written, that is also visible.
Yes, sir, it's visible.
Yes, yes, sir.
So we are talking about this. So some current will come here, okay, I1. If it is okay, some current will. This is I2. Then this will be. Let us say this is I3. This is I4. Correct. And some current will go here, I5. So basically, it is a node, correct, where some lines are connected, then some transformer are connected, then there will be some outgoing lines, some incoming, okay. And it is basically the summation, Kirchhoff's law, sigma I must be equal to 0, correct? Correct or not?
Yes,
Hello?
sir.
So
Yes, sir.
now this how we first represent. Now here this is called, now there will be in a substation, you have to maintain the substation. So there will be some bus scheme is required, bus switching scheme, okay. So like that there will be a breaker, there will be a breaker, there will be a breaker, correct, so that it can be, the faulty section can be isolated, correct. So now let us say this is a 400 kV 400 kV bus, and this is a 220 kV bus, okay. Now we have to design this substation, the 400 kV bus, 220 kV bus. Design means different voltage ratings, current ratings, and different problems, different issues, maintenance issues, design issues, okay. So first, when we start the substation design, we have to have, or we have to adopt some bus switching scheme, correct? Understood? Some bus switching
Yes, sir.
scheme. So now that bus switching scheme has different merits and demerits. So without bus switching schemes, design of substation, the first step is basically to select a bus switching scheme, correct? Depending upon their merits and demerits. Okay. Now there are various considerations when we selecting bus switching scheme, and after bus switching scheme there will be layout, okay. So layout is the bus switching scheme is basically a single line diagram, and then it is converted to a three phase ROIV phase three phase diagram, then it is a layout, and how we place on a land, that is a layout, correct? Correct. Hello? 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 Hello?
Yes, sir, you are audible, sir.
Okay, so nobody is responding. So the first criteria is that it should be reliable and secure, and that is selected. This is a consideration for both layout as well as bus switching scheme. That how we select a bus scheme, that depends, and the reliability, security depends also on bus scheme. Then the ease of maintenance, how easily it can be maintained. Then operation flexibility, how what will be the flexibility in operation. Basically, if there is manual operation means less flexibility, and it is automatic means it is more flexible. Correct. Then okay, short circuit. If in the power system there is inbuilt that if there is a fault, there will be some short circuit current, heavy current, and everywhere there is a short circuit level. Correct. And again, the shape of the land. You know that if some bus switching scheme were adapted and a layout has been developed, then it may not be accommodated in the land available, especially in this hilly areas where the land is limited or some constant because of litigation. You may not get a land of your the shape of your choice. So that way, if the land is a different size, so the layout will change, and if layout change, sometimes if the land is less, then the bus scheme may be a different one. Okay. Then altitude of land above mean level. You know that that if the altitude of a land or of a substation of a location, let us say in hilly area, Kashmir, or in Bhutan, okay, or in Sikkim, Arunachal Pradesh, there are substation locations where there is above 1000 meter above mean sea level. Okay, understood? So when you go higher altitude, the dielectric property of air is deteriorated actually. So you have to have more clearances. Okay, because air is the insulation and air has the dielectric property. When air pressure drops, the clearances, the dielectric property also affected. So you have to have higher clearances. Then next is the feeder orientation. I'll come to that when we'll talk about the layout. Then safety of the equipment and personnel means we have to put some earthing switches, okay, for the earthing purpose. Then layout should be such that because the load is always growing, there is always load growth. So the substation layout and hence the bus switching scheme should be such that in future any feeder can be connected or any transformer, any element basically can be connected, and finally it should be cost effective. Correct. Now, what are the bus switching schemes? Basically, you know, there is this type of schemes: single main scheme, then a double main scheme, single main and transfer scheme, and double main with bypass isolator scheme. Then there is double main and transfer scheme, and 1.5 breaker scheme, then double breaker scheme, and ring bus scheme. Now we will go one by one. Okay, about the scheme. So this is a single main scheme. This is visible. Hello.
Yes, sir. Visual. Visual.
So now I'll try to draw this something here. Okay. So it is basically this is a bus. Okay. And then every feeder has to be a circuit breaker. Correct. Hello. Hello.
Yes, sir.
You have to respond. Every feeder you need a circuit breaker. This is a circuit breaker. Okay. Hello.
Yes, sir.
And then you both side you need isolator. Okay. For what is the function of circuit breaker? Any idea?
Break the circuits.
Circuit breaker is
During fault
capable
circuit,
This is interactive because it's substation design. It's not something that other lecture.
during fault current. Circuit breaker is capable to break the fault current.
Yeah, it is basically on load switch. When there is a fault, the breaker should trip, okay, and isolate the circuit, the faulty section. And the isolator here, this isolator is just to isolate the physical isolation, so that breaker can be, if some problem in the breaker, immediately after tripping the breaker, we have to isolate the section, the feeder from the bus and from the breaker. So there will be one isolator from the line side and another to the bus side, so that the breaker can be isolated for maintenance as well as just to have a physical isolation. Okay. So there will be another feeder, another breaker. So substation not only one feeder. This is something like in our the supply in our houses also. This is a single main. This is a single main bus. Okay. There may be another feeder. This one this is maybe a line. This is a line. This is this. Okay. This may be a transformer. Okay. This may be a capacitor bank. So this may be a capacitor bank or maybe a reactor. Okay, so this is a single main bus. Okay, single line diagram. So actually there is three phases R, Y, B, but here for purpose of current summation, so some current will, this is basically voltage Kirchhoff's current law, sigma current, and the feeders will be distributed such that that currents are also distributed. Okay, like that here let us say this the current is coming this way. Current is coming this way, okay, and this way. So this will go this way, and this is also generator. So what will happen if this is I1, this is I2? So from here the current will be I1 plus I2, correct? And here it will be I1 plus I2. But if a transformer is distributed like this, here we have one more transformer. Okay, so some current will go here, and here is the stress because of summation. So all the incoming lines should not be at the one end, and all the outgoing should not be at the other end. Then because the design has to be for the worst case. So this will be here will be the maximum summation, and current means everything the conductor design, it will affect the design. Understood? Now here, suppose we want to the line has stripped, and we want to line has stripped means the breaker has stripped, and so there is some problem in the breaker. So what will happen? Can we do the line? Can we switch on the line? No, because every feeder is connected with one breaker. Okay. So here this is simplest because every feeder has one circuit breaker and associated isolators. Okay. Of course, there are since this is bus switching scheme. Okay. So we are not showing here the current transformer, CT, and other associated equipments. When we will talk about the layout, okay, we will talk about that. This is only about the bus switching scheme, and based on the merits or demerits, I have already told, we have to select a bus switching scheme, and based on that we will go for the substation design. So here the merit is that it is the simplest. The quantity of switchgear like isolator and circuit breaker are minimum. Okay, but the problem is if there is a fault here, if there is a fault here, what will happen? If there is a fault in the bus, what will happen? Hello?
Fault current is flow in this path.
Yes, sir. Yes, sir.
A fault current will give, and all the bus, actually the substation will be under darkness.